So we've seen a few examples of how to find a derivative using its limit definition, but now I really want to turn to the interpretation of the derivative and really understanding what the derivative tells us and why we care about that so much. So the thing I'm going to come back to, I'm going to say this 1,000 times, the derivative is what tells us the slope of the tangent line. I think that this is the most important interpretation of the derivative for our class. Because if we understand what the derivative is doing at a certain point, we can understand what the function is doing, what the original function is doing at that point, and vice versa. If I understand the behavior of the function, I can then also say something about the derivative. So let's talk about what that means here. First, it says, hey, if the sign of f prime is positive at a certain x value, then the graph of f is increasing. And alternatively is also true, or excuse me, vice versa is also true. So if I know that the graph of f is increasing, then I can conclude that f prime must be positive. So if I were to draw just an arbitrary function over here just to get an example, I'm going to pick a point, and let's call this function f of x here. If I were to pick a point where f is increasing, I'm going to pick this point right here. My function is increasing at that point. And okay, now I want to see what I can say about f prime. Well, f prime, remember the derivative tells you the slope of the tangent line. So I'm going to draw in the tangent line. Let's sketch that in. It's going to look something like this. So I don't know the exact value of the slope of the tangent line at this point, but I can look at that and say, well, my line's going up, so my slope must be positive at that point. And you can do that for any increasing function. If you look at a point where your function is increasing, sketch in the tangent line, I promise you that the derivative, the slope of that tangent line will be positive every single time. If the graph of f prime is negative, then the graph of f is decreasing and vice versa. So this, I think, kind of makes intuitive sense. We can look and see also, vice versa, where the graph of f is decreasing, and then that will allow us to say where f prime is negative. So let's try that here. So if I pick a point where where f is decreasing, where my graph is going down, I'm going to pick this point right here. My function's going down at that point, and I were to sketch in the tangent line here. So here's my tangent line. It looks something like this. Again, I can't find the exact value of the slope of that tangent line, but I can say, you know what, at that point, that line is going down, it's decreasing, so my slope must be negative. So this is very cool. I can kind of look at the graph and I can make conclusions about the derivative, or vice versa. I can look at the derivative and I can make conclusions about the value of the graph or what the graph is doing there. The one case we haven't talked about, and I want to make sure that we just mention it here and see a quick example. We said, okay, this is what happens when f prime is positive. This is what happens when f prime is negative. What if f prime is 0? What does that look like? Well, if f prime is 0, it can't be increasing, because then the derivative would be positive. 0 is not a positive number. The graph of f can't be decreasing, because then f prime would be negative, and 0 is not a negative number. 0 is neither positive nor negative. This point right here is an example of where I would have a derivative of 0. And if I look at that point right there, I have a horizontal tangent line, or as close to a horizontal tangent line as I can draw. Horizontal lines, I know, have a slope of 0. And if I talk about that point right there, that point is neither increasing nor decreasing. Could have also picked probably right around this point right here, if I had to estimate, is another place where I have the derivative equals to 0. These points are going to be tremendously important for us later on, and actually for us right now, because these are places where our function might transition from increasing to decreasing, and then, well, if we transition from increasing to decreasing, then the derivative is going to transition from being positive to negative. So let's look at an example here. We're going to look at an example. We're going to start with the original function and see if we can't come up with a sketch of the derivative. So here, I'm going to use the graph of f, so this is f of x here, to sketch the graph of f prime of x, or a rough interpretation of f prime. So I am starting with the original function f. I want to look for where is my function f increasing and where is my function f decreasing. So I'm just going to start over on the left-hand side over here. I'm just going to pick the leftmost value that I can. And I'm just going to think about, okay, what's my function doing over here? Is it going up or is it going down? Is it increasing or is it decreasing? Well, looks like it's decreasing until I get to about this point right here. Now, what's that point? I really care about that x value. That x value looks like -1. So okay, I'm going to see if I can find a way to organize this information. I think the most important, or kind of the easiest way to organize this information, is to construct a number line. We can kind of see a visual representation of the derivative. So we've said, okay, something's happening here at -1, and actually if you sketch in the tangent line there at -1, I can look, I've got that horizontal tangent line right here, which tells me that the derivative must be 0 there. That's going to be a really, really important point for us. I'm also going to look at, okay, we talked about the behavior on the left-hand side, so over here on the left-hand side, we said our function is decreasing. Well, if the graph of f is decreasing, then we know that the derivative must be negative. So I'm going to put a negative sign on the left-hand side of -1 so that I know, hey, the graph of f prime is negative on that interval. So let's actually sketch what we know so far here. So let's sketch in, we know that we have the derivative is 0 at -1, so the derivative has a y value of 0. I'm going to sketch the derivative in blue here. The derivative has a y value of 0 at -1, so I know I have an x-intercept for my derivative at -1. And all I really know is on the left-hand side of -1 so far that my derivative is negative, so it should be below the x-axis over here. It should be below the x-axis. And I don't really know what it looks like then. To be honest, there's not really a great way that I can do it, or that I can know right now. One way we can get a little bit more information is to actually look at what's happening to the slopes of the tangent lines. So if we were to sketch in the slope of the tangent line as we move further and further away from -1, there's one, there's one, there's one. So if I look at the slopes of these lines, I see that, now ignore the sign for just a second, these lines are getting steeper and steeper and steeper. If the lines themselves are getting steeper and steeper and steeper, that means that the slopes of those lines are getting bigger and bigger and bigger. They're just going to happen to be bigger and bigger and bigger negative numbers. So what that means for me is as I move further and further away from -1, my y value should be getting bigger and bigger and bigger in the negative direction. We should see something that looks like this. If we understand the left-hand side, I think the right-hand side will come a little bit more naturally. So what's happening after -1? So we said, okay, we've got this horizontal tangent line right here. And if I kind of trace my function, what's going on after -1? Well, my function looks like it sort of rebounds, and then after that it's going up, 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 up. It's increasing, it's increasing, it's increasing. And so what do we know? If the graph of f is increasing, then f prime must be positive. So I'm going to put a plus sign over here on the right-hand side of -1 to show that my derivative must be positive. So let me finish drawing my derivative in blue here. On the right-hand side of -1, I can look, hey, the sign of the derivative is positive, so the y value of the derivative is positive. We should see something that looks like this. And so let me just clear this up. The blue graph that I've drawn right here, this is the graph of f prime of x. That red parabola that I started with, this is the original f of x function. So this is an example. We're going to be using this idea of a number line a whole lot in this class, so I would definitely take a look at some of these practice problems just to get a little bit used to organize your information in that way. Let's look at one more here. I'm going to sketch the graph of g prime using the graph of g. So this is the graph of g of x right here. I'm going to see if I can construct the graph of g prime, of the derivative. So again, I'm going to look for what is my function doing. So this time as I move from the left-hand side, if I start way over here, what's my function doing? Oops, let's do that in blue. My function, it looks like it's going up, so it must be increasing. Where does it stop increasing? It stops increasing, looks like right here at x equals 3, I see that horizontal tangent line. Be on the lookout for those points. So okay, if I want to talk about what g prime looks like, I know that on the left-hand side of 3, right, because that's where we have that horizontal tangent line. On the left-hand side of 3, we said my function is going up, it's increasing. My function is going up, derivative must be positive there. And then, okay, what do we know about at 3? At 3, we had that horizontal tangent line right there, so the value of the derivative must be 0 at 3. And then, well, what's happening after that? After 3, my function starts to go down again. It's decreasing, so I know that the sign of the derivative must be negative on the right-hand side of 3. At this point, I think I've got pretty much everything I need. I'm going to start with this part right here. I'm going to start with that x-intercept. So I know that my derivative should be crossing the x-axis at 3 because I have that y value of 0. On the left-hand side, I know that my derivative should be positive, so I should be above the x-axis on the left-hand side over here. And on the right-hand side, the derivative should be negative. It should be below the x-axis over there. So these are really good problems. I really like these problems because they really do force you to understand how is the behavior of the function related to the value of the derivative. And this is a really, really important idea we're just going to keep coming back to over and over and over again. So I think these are really, really nice problems to practice.